So I would like to start off with the Fourth Amendment of the United States Constitution. This is a very powerful statement. It basically ensures all U.S. citizens that they have privacy in their private effects. Basically saying that anything you keep in your house, in your car, anything that you conceal basically is considered private. But since at least the 1970s, the laws have been changing so that the privacy has been eroding, basically. There's a famous court case, a Supreme Court case in the United States versus Miller, and it's basically about checks. I mean, there's a long story behind it, but basically they subpoenaed checks from a bank, and the Supreme Court deemed that this was okay. You do not have any kind of privacy with any information that is given to a third party. So the bank is considered a third party. Therefore, because everybody in a bank has access to your checks and your account, it basically means that you do not have privacy in this. So, I'm sure everybody here wants everybody to see what's in their bank account, right? That's not private at all, right? So, since the 1970s, we have now moved from paper to digital. So you started off with checks and had no privacy in your checks. And now you have all kinds of digital information that's going through the government, through smartphones, through financial institutions, and social media. Now, some of this stuff you actually do want public. For example, a lot of things that you do have in your social media, you expect everybody to see. But most people don't really want their bank account information plastered across the entire world, right? And they're permanently for everybody to see, because unlike paper, which is one copy, digital can be done multiple times over and can be stored in almost permanent fashion. So if somebody wants to see something, they can see it. So what is a solution to all of this? That's not the right title, I'm sorry. What is our solution? Our solution is three-pronged. It's encryption, cryptographic hash functions, and digital signatures. That is, together, they form a very good solution, for at least the moment. Maybe in the future we need something stronger, but for now, we're going to go into these three. So, what is encryption? Encryption basically takes a message, funnels it through a cryptographic algorithm, and then on the other end, it produces something that's completely unreadable to the average user unless they have the key to decrypt it. So, for an example, what you're seeing right now is actually taking the message on the left side, pushing it through a symmetric encryption algorithm with the password is ASDF. Well, we're showing you the password. So basically anyone can take, if you see the phrase in between the lock, you can actually take this on a Linux computer and produce the exact message on the right. But in this case, I gave you the key. So it's not exactly super secretive, but it's just giving you an idea that if you didn't know the key and you saw this PGP message on the right, you would have no idea that it says what it says on the left, right? And so that essentially is what encryption does. I know people hear encryption like it's a buzzword, but I don't think people actually go into it and think about what encryption actually is and how it produces. So we're going to go a little further. But mind you, I can spend months on encryption alone, and then another few months on digital signatures, and another few months on hash functions. We're doing all of this in half an hour. So there's symmetrical encryption. It's basically one key, which is similar to a password, as you saw before. So it's really good if it's just something that you want to keep secret from the entire world. You have one password, and it's all yours. You don't have to share it with anybody. But if you do have to move a message between each other, you can say the password in person, but what if that person is halfway across the world? That's kind of impossible. And you need to keep everything secret. So another solution is asymmetrical encryption, where you have one key for the encryption and another key for the decryption. And that requires two keys, basically, and it's easy to send the public key across the world for that person to encrypt it, and then only you can decrypt it and see the message. And then you do it vice versa. So the message that you're sending over is encrypted with their public key, and they're going to decrypt it with their private key. And hopefully that was clear, because we don't have more time to go through it. Cryptographic hash functions. So there's about 4 exact formulas that you need for a good cryptographic hash function, and we don't really have time to go in it. So I'm going to shorten that. It basically takes any kind of message, funnels it through a cryptographic algorithm, and produces the same exact length output. As you can see here, when you do hello through the SHA-1, it produces exactly the same amount as if you did hello world. It's a one-way function, which means that you don't actually decrypt this. It's only for an output. So you should never be able to take the output on the right, and then produce the input that's on the left. So for the first example, you should never know that that's going to be hello. If you can do that, it's a really bad hash function. But this is very useful for ensuring the integrity of data. So basically, it's not used to sit there and confiscate the data, convolute the data, I think is the right word, but it's basically used to make sure that it's definitely what you wanted to say. And this is actually used in a Merkle tree in, let's say, Bitcoin blockchain or other blockchains, but most people don't talk about it. It's also how you produce a lot of the public addresses that you use for the blockchain solutions. There's a lot of applications for cryptographic hash functions, but we're going to move on, so hopefully you guys understood in that 5 seconds. Okay, this is missing a title, but this is supposed to be about a digital signature. So what is a digital signature? It's supposed to use a public-private key solution. So I have a public and a private key, and I sent over my public key to my friend. Let's just use Alice, my friend Alice. And so I have a message, and I basically encrypt that message with my private key. And I basically then send the encrypted message over to my friend Alice. Now, Alice should be able to decrypt this with my public key that she already has. And when that is done, she should be able to see the message. Now, we both know what the message is, and so it's just certain that this is my key, basically. And that is what a digital signature is. Hopefully that was clear. I'm really sorry. This is very complicated stuff. So basically, how do we use all of them as a solution, right? So encryption is basically what's going to help us start by keeping anything you want private, private. You can put any of these things on the cloud, and if they're encrypted, as long as they don't have your private key, they should stay that way. With strong enough encryption, they can see everything but not understand it, as we recall before when I showed the encryption output. But also, let's just say that we want to prove that this is mine. Well, we're using the cryptographic hash functions with my digital signature, and then I can prove that I sent something. That's really mine. Even if I want it in the clear, I can prove it. So let's just say that I want to post something on social media. And I want the whole world to see, so I'm not going to encrypt it. I really just want to post something and it's going to be public. So I can sign it, post it over, and let's just say Facebook decides, maybe I should not have named them by name, but let's just say that Facebook decides that they want to put it as theirs, that they own it. Well, if I put it on my own social media first, which we'll get to in a second, and I had digitally signed it, that is my copyright. I mean, I didn't file it with any government. They don't have to really know about it, but I know it's mine because I can cryptographically prove that that's mine with the digital signature. But it's still public, right? So now the whole world can see it. Hopefully this will also hold up in a court of law, but we have a lot of lawyers here and they'll be able to tell us more about that. So putting that together, I belong to TigoCTM. I'm a co-founder, and we're building hardware that is utilizing all of these things in a hopefully very usable fashion. That is our goal. And also everything is going to be open source. So we're going to sell a computer. All of our hardware is going to be open source. Hopefully all of our firmware is going to be open source. And we are going to be using an open source operating system called Gold OS. On this, anyone can see the source code. So if you decided that you wanted to make changes, it's your computer. Go ahead. We're not going to stop you. We will help you, but those changes are yours. But for somebody who just wants to keep everything secure, we have everything going in a little tiny USB type stick that's going to keep all of your private keys private. And hopefully you're going to be able to start your computer the same way you kind of start your car. You just plug it in and it has everything. And it's already encrypted for you because as I went through, as hard as it is to understand encryption, actually using it is not so much easier. I've gone through this for many, many years, and every time I've had to set up an encryption key, I'm going to say a PGP key that most people haven't used, but if you've used it, you know that it's not really for the average person yet. It's very difficult to set up if you don't understand it. And so we're trying to make that easier. We're trying to bring it out to the masses so that you can almost plug and play. It doesn't work with Microsoft Outlook, for an example. You have to do something else if you want to encrypt your emails. We want to make this easier. But we also want to make it so that if you want to change these options, you can. Right? If you want more advanced solutions, if you want more control of it, you can do that too. We're not going to stop that. But let's just say a law firm. Law firms have a lot of sensitive data. They want to keep it private. So we would have a whole bunch of computers all set up for their law firm where they can keep stuff in the cloud and they can have it anywhere they want, but it's still private to the average person. I know law firms that are using Gmail. And Gmail has explicitly said that Google owns those emails. So all of the conversations that you're having with your lawyer that you think is private actually goes through Google. And then it becomes part of that third party. And then going back to the court case, which I think I'm going the wrong way, going back to this court case, Google has the right to see those emails because you signed that. So now all the US government would need is a subpoena to get those emails. So this private conversation that you think is private is not. And this all has to change. And so we're going to try our best to change it, but we also need users, and we need people to help us, and we need improvements because we don't know if this is easy or not for you.